Okay, so I'm just going to create, so whenever you're dealing with particles, they only work with polygons, not with NURB surfaces. We don't really do NURB surfaces very much anyway, but I'm just going to create a polygon plane, and I am recording this so I can give you this video after. I'm just going to scale it up a bit. And I'll call this membrane. So this isn't going to be the ultimate membrane, but this is what the particles will stick to. I'm going to delete its history. And now, all the nParticle stuff is down here at the bottom. So I'm going to go to create nParticles, but before I choose one of these methods of creating them, you can choose what type of particles they'll create. Points, balls, cloud, thick cloud, or water. We're just going to use balls because they will self-collide. They'll bump into each other. So we can just leave it like that. You can always change this after it's created too, but. And then finally I want to go to emit from object. So I'll call this is my lipid emitter. So we have to create an emitter, so it's the thing that produces the particles over time. And then in this case, the emitter type, omni shoots them off in all directions at once. Directional shoots them in a direction. Curve emits them from a curve, but we want to select surface because we want them to emit from a surface. This is the number of particles per second. I have to give myself some more time here. 1,000 frames. So 100 particles per second doesn't really matter. Now this is important. Need parent UV. Even though it says NURBS, you should still turn it on. So what this means is a particle that's emitted from a surface, like this plane, is emitted from a unique address on the surface, a UV address. And so when you have that clicked on, it just records that address. It says, particle 17 was born at U.5V.78, and that's its birth address. So that's what parent UV means, its birth address. So we want to record that. You can always turn that on afterwards too, in case we missed it. And then things like this, we can always change this after, but everything should be set to 0. We don't want the particles to be born and then shoot off. We want them to stay on the surface, right? So speed should be 0, and so on. So I'll just click Create. I'm going to open the outliner. So when you create a particle system, so there's the membrane, the surface that I created, and then you can see there's something grouped with it. That indicates the emitter. So I called it lipid 1. So it is emitting the particles. Then you've got the particle shape itself, the particles that are created. And then you've got this thing called the nucleus, and that's the global settings for the environment that they live in, the universe. It's got gravity and wind and things like that. And so all the action happens here in nParticle. The shape, the particle itself. There's a ton of stuff in here. So let's try and just focus on the things that are important. So the first thing we want to do, because by default these particles will be caught by gravity and be pulled down. So in the nParticle shape, partway down here you can look under dynamic properties, tell it to ignore solver gravity. So nucleus is the solver, so that's the physics solver in mind. So you were just saying, just ignore the gravity. We could turn off the gravity, but sometimes you want gravity on for one thing, not on for another. So it's going to ignore the gravity. So we can just play the animation now. Oh, and one thing I should say, it's different than when you do typical animation, or keyframe animation. Remember in the preferences I said under time slider to be on real time? When you use particles, you have to be on play every frame, because it has to evaluate the position of each particle on a frame-by-frame basis, so it can't skip any frames. Again, this should be in the wiki. Let me just double check. Or maybe not. I found this somewhere. Okay, so if I just play the thing now, you can see these particles are just born all over the surface. You can see when two get too close to the other, it bumps it out of the way. If I hit the shaded mode, you can see that they're actually little spheres. You'll see them shift when another one bumps into it. So right now these are pretty small. It's going to take a long time to fill up this plane. So if I open the attribute editor, let's look at some of the things we can change here. On a global basis, we can change the particle size. It's like the third one down here. The radius is 0.2, so I can change it to, say, 0.5, and so now they're bigger. I have to replay the animation because it'll play out differently now, because they'll bump into each other in a different way. So we can play until it kind of fills up the space. So that's good.
It's like an Easter egg.
Yep, it is. Happy Easter. If we look here under count, see these ones are grayed out. We can't change it here, but it gives us an idea. There are about 600 particles. So in this case, about 600 is probably enough to fill up this space. Maybe a little more. Give it 620 or something like that. So in the particle, you can set the limit on the number of particles that will be created. And that is down a little bit lower under emitter attributes or something like that. Emission attributes. So that's not a keyword, emission attributes here. And again, I'm recording this so you can review it. The max count is set to -1, which means infinity. It'll just keep going until my computer starts smoking and dies. But we can change this to 620. And so when it hits 620, it'll just stop. So I can rewind and play again. So soon, yep, so now they've stopped being born, and even though the time slider is still going. So now we've got a surface kind of covered with these. So this is good. But the only problem here is that it looks like they're stuck to the surface, but they're not. They're just born on the surface, but if I were to deform this plane, they wouldn't stay stuck to it. So what we have to do is to tell, so just plain speaking, we have to say to the particles, where you're born, that's where you stay. So we have to write an expression to that effect. And so when you're dealing with particles, you can deal with them on a global level. So changing the count or the size, that's all of them change at once. Or you can do a per particle basis. So if I scroll down a little bit more, there are all these things called per particle arrays. So you can set conditions so different attributes will dictate which particles are bigger than others, which ones move faster than others, that sort of thing. What we want to do is set an expression that says, look at where you were born and then stick to that spot. So first of all, we have to tell these particles to have this plane as their goal. They want to get to that plane. So select the particles, shift select the particles, the plane, and go to nParticles goal. So that means the plane is the goal. They try to get there and try and stay there. So I'll just click create with a goal weight of 1, so 100%. And now if I play the animation, you'll see it acts totally differently. They try and stick to the vertices, and when they can't, they start fighting with each other. Because they're all trying to stick to the vertices. Because when you set a goal for something, the only thing it knows about that surface is where its vertices are. So that's what their goals are. So we've set a goal, so it knows what thing to stick to, but it's not sticking to it very nicely. So now we have to tell it to stick to the spots where they were born. So and now this is also described on the wiki in the first section, this goal U, goal V thing. So I'll describe that now. So first of all, you can see we asked it to record parent V and parent U, and here it is here. But I don't see goal. I see goal per particle, but I need goal U and goal V. So we have to add that dynamic attribute. So under here it says add dynamic attributes. Click on general, and we can find goal U and goal V, add those two. Then we just have to write a simple expression in the creation expression. So if I goal V, goal U, you can't type in here. You can right click and add an expression. So creation expression, so that means when they're born, execute this expression. And so my expression is goal U, so the position I want them to stick to, goal U, should equal parent U, their birth address, right? Semicolon. Goal V, the place I want them to stick to in that dimension, should equal their birth address in V, parent V, and say create. Okay. And just to test to make sure this is working, I'm going to deform this surface over time. So let's see if they stick. Actually, no, I'm not going to do that yet. Play the animation. So now they try to go to their address, but you can see they're kind of bumping into each other because their addresses might overlap a little bit. So there are a bunch of things we can do to try and settle them down. There are actually other ways to do this, and this might not be the absolute best way, but we can try. So if I go back to the particle and just go up towards the top under collisions, self-collide is turned on, so that means they want to bump into each other. And they have a collide width scale, so if they can have a collide border that exceeds their size. But then there's a self-collide width scale, it's set to 1. So I can set this to smaller so they can intersect with each other a little bit. So they can kind of overlap a bit. So now that should keep them from bumping too much. So still a little. But you can see there are some gaps there now, right? Because they're not being pushed out of the way so much. So we could fix this by turning off collide, self-collide altogether, and then just fill it with way more particles. That's one way you can do it. But now, let's say we want them just to sort of jitter around a little bit on the surface. We can write another expression. This is back under the per particle. Okay, so instead of a creation expression, we can say runtime before dynamics expression. So we can say goal U equals goal U. And remember, U and V are always between 0 and 1. So I can say plus a random amount between the values of negative 0.001 and a positive value of 0.001. So we'll just randomly select a number between those. Semicolon. I'm just going to copy, paste it, but change it to goal V. Now if we play, see how they're sliding around a little bit. They're kind of jitter. But that's how you can add a little bit of movement to your thing. So the last thing to do is either you render them this way as these particles, you have to fill up the space more. You have to probably fill up the space more either way. So you can render these in mental ray. Oops. They've got reflections turned on, so you can change the quality of the surface, the color, and things like that. But you can render them straight like this as particles. These are called blobby surface particles, or you can convert this to a polygon mesh. So you select the particles and go to Modify, Convert nParticles to polygons. And you can look this up in the on the wiki, I think, under cell division using particles. I think it includes something about this in there. So now you can see it's created a polygon mesh. From here, if I play the animation, you can see that it moves a little bit as the particles move. You can change the qualities of this mesh in the particle itself again. Under Output Mesh, And you can change things like the scale of the blobby surface here, so you can make it bigger. The mesh triangle size, so how big those triangles are, so the smaller the size, the more detail you can get. And then the type of mesh, this is triangles. Change it to a quad mesh, smooth it. So you can see you get sort of a representation of those particles underneath there, but again, there are a lot of empty spaces we'd have to fill up. But with a polygon, you can just add any kind of shader to it you want. So now it's a real polygon, so you can shade it just like we've shaded anything else. Now my computer will go super slow mode because it has to track the position of the particles and figure out how they overlap with each other and then generate this mesh on the fly. So now that we're up to 620, it's really sluggish. But essentially that's what Diego did for his. He did this. Now, what he might have done to make it a bit different, to work in a different way, is instead of having particles born on a surface, he may have made a cube, like a volume, and then filled it with particles, and then trapped them inside of it. So you have a single layer of particles, but they're bounded on the top and the bottom rather than being stuck to a surface through their middle, and then stirred them up with a turbulence field. That's another way to do it. I'm not sure what he did. In fact, that might have some benefits too. Let me just quickly build that one, and it'll be part of this video too. So I'm just going to save this. Again. So we'll create a new file. We're going to do all this later in class. I'm just showing Mansa, and I'll put this video up online in case somebody wants to look at it. So I'll do another way of doing this. Make sure I'm on play every frame. So if I create a polygon cube, and just scale it up so it's kind of flat like that, and I might give it some more dimension. Instead of emitting a particle from a surface, you can fill a surface with particles, or an object with particles. So select this cube and delete its history, and go to nParticle, create nParticles, balls again, and then fill object rather than emit from object. And then you have to set the resolution. So this is the number of divisions you'll have. So I don't know, I'll just try 10. Close packing, turn off double walled in this case. Double walled is if you have, like you made your flask earlier in class. If you have double walled turned on, it'll fill the flask like you would expect it to. If you have double walled turned off, it will fill the inside of the wall. But here I don't have that, so I want it to fill the inside of the wall. So particle fill, particle fill. Interesting. It looks like it's doing it, but I'm just not seeing it. No, there's no particle. It might be that this thing is too narrow. Oh, there we go, yeah. The particles were too big to fit in there, so I just stretched it up. So now you can see it's filled with particles. I'm going to turn this thing so it's not renderable. Just want to hide this. Actually, before I do that, the other thing I like to do is make this a collision object so the particles can't escape. So if I select this cube that I filled with particles and go to nMesh, create passive collider. That means it's a collision object. So now, I'm just going to hide this. So the particles moved a little bit because they're trying to push each other out of the way. So now they're just kind of sitting there. Now if I want to stir them up, I probably have to turn their collision down so they can move around each other a little bit. So back in the particle, self-collide width scale 0.5. So now they're freer to move around. And then I can select the particles and go to fields, turbulence, and I'll create a turbulence cube, magnitude of 20. So now we've got them all kind of swirling around. Like this, so if you want to make... Actually, this probably works a little more smoothly than the other way. Now, there might be... You can see the patterns in the turbulence here. So you can go into the turbulence and start changing some of that stuff. Like the... Oops. The frequency is set to 1. We may want to change that to 10. So how detailed it is. The noise level, we can turn that up. Yeah, this is actually looks much more like his. And so now you can see they're bumping into each other, but still trying to push each other apart. And you can kind of make an active lipid bilayer like that. I don't know if lipid bilayers do this or not. Who knows? But then the same thing, you can select it, and if you want to, you can go to Modify, Convert, nParticles to polygons. And change the output mesh. And you just start tweaking all this stuff. Oh, I might crash. This is dangerous what I'm doing here. I'll try and keep it sort of low. I should be able to play. But now I've got it kind of swollen so you don't see the individual particles so much. But you can, by reducing the mesh triangle size, it'll stick to the particles a little more closely. So that's what he did for his. He used particles. I think actually the second method is probably what he did. Put them inside a container. And then to make that container move, he had to animate that box that they were in or whatever they were in. Place to start. Yours is just like a, sorry, it's not really deforming.
It's not really deforming. I just wanted to...
Yeah. Okay. So I'm going to finish this recording now. Do you have any questions before I stop?
So what I wanted was, it's not what we were initially the receptors, okay?
Mm-hmm.
I wanted it to be the same with my nuclear core, so I have a nuclear core now, mechanical.
Okay.
So how would I
Make a hole?
Yeah.
Um,
Or render it.
you would, in that case, if you do this method, then I would, at the beginning, put a collision object that's going to separate them. So let's say I create a polygon cone. And have it down here, and then I'm going to animate it moving up to make that hole, because otherwise they'll be born inside of it. I'm going to turn this into nMesh Create passive collider. And then animate it moving up. Set key, and then maybe over 2 seconds. Who knows if this will work. I'm just going to delete this mesh. So I help you guys with your shots in a minute. It's stuck. So there, I've got our particles back. Now we'll watch the animation. It should push through and make a hole. So now, and then this can just be an invisible object, so they won't. So they can be moving around it. You don't see it. That's probably the best.
It would push the spheres around. As this moves around.
If it moved around, yeah, then it would move the sphere. So if you had a receptor on the surface that had an invisible collider around its base that it was attached to, and you slid that around the surface, it would push all the things out of the way. Yeah, so that could work. And actually, one of the benefits of doing it this way, where they're inside that box, is that they have to stay constrained in there. So as it pushes them out of the way, they don't just push out; they fill in the space behind it. Actually, that would work better. Okay.